Okay, question 3 asks, what is the estimated position of the boat 2 hours later? So, at time 0, we know the boat's here. The boat has had its engine disabled. So in other words, it's unable to move of its own accord. The only thing that's going to dictate the motion of this boat is the current now. It's just going to drift in the current. And this current here is known to be 2 knots due south. Well, we know that north is up the page, so therefore south is down the page. And 2 knots, is a nautical term that we need to think about. So 1 knot is just another way of saying 1 nautical mile per hour. Just in the same way that we might say that 1 kilometre an hour is 1 kilometre per 1 hour. 1 knot is 1 nautical mile per hour. So now that we know this, we can see that if it's 2 knots due south, we can see that 2 knots equals 2 nautical miles per hour. So within each hour, the boat will drift 2 nautical miles. Therefore, after 2 hours, boat will drift 2 times 2 knots. So, fairly simple maths there to work out that it drifts 4 nautical miles. Now that's not a scalar answer, that's a vector quantity, because we know that it goes in a southerly direction. So therefore we can say, let C be our current. C is our current. Well, for our current, we actually can ascribe a displacement to that. The displacement we were given is 2 knots per hour, and it's also got a direction as well. That's an important one to get right. We can say that that's south. So if north is 0 degrees with bearings, that's just out of shot there. There's north. That's 0 degrees. Well, if we want to go south, that's going to be 180 degrees. Okay. 180 degrees T. I'm using T to stand for a true bearing. True bearing means it's measured from north and it's measured in a clockwise direction around 180 degrees. When I'm going to apply maths to this later, I won't be able to use this bearing. I need to adjust it so that it's in polar format. And if we go back here, we can see that if we're measuring from the x-axis, or east, that will be 90 degrees to here, 180 to here, around to 270 there. So this actual is 270 degrees. C. Okay, this will come in handy shortly, but for now we just need to think about the fact that this current has carried the boat 4 nautical miles in a southerly direction. Well, if that's the case, again, we'll put the protractor down. We know that it's gone in a southerly direction, down this way in this direction. And then we simply need to measure. It's gone 4 nautical miles, and 1 nautical mile is 2 centimeters, so that's going to be 8 centimeters. So 1, 2, 3, 4 centimeters. That's 2 nautical miles it travels in the first hour, and in the second hour it goes another 2 nautical miles. So here's its position now. We'll mark that in as a vector. And then the question asks us, what's its estimated position of the boat 2 hours later? Here's the position of the boat.